Alright, good people, this is section R-3, the third section in the review chapter. It's addition, subtraction, and multiplication of polynomials. Dang, we gotta go over what a polynomial is, then we have to figure out how to add them together, and how to subtract two polynomials, and then how to multiply two polynomials. That's a lot. It's gonna be 3 pages of stuff, so I'm gonna try and not make this too long of a video. That means, I don't know, maybe I might go a little bit faster than usual, so if I say something and it's completely foreign, then please write down a question, and I want to know about it, and I want to help you get it answered. You can Google it, you can text a friend, you could email me. But if those 3 options are just not very appealing, then go ahead and write down your questions. I want you to write down questions. I'm requiring you to write down questions. It's something you got to do. Also, for an audio check, I'm just going to let you know that I'm going to be making sure that everyone is listening. And how am I going to do that? Well, I'm just going to let you know that sometime during the course of this video, I'm going to drop some personal information about myself, and then when I do that, just write it down for the audio check. All right, polynomials. Here's a table that I think will organize a lot of the vocabulary that you might see. Check this out. This right here is the 1.5 x cubed plus 9y. This is a binomial because it has 2 terms. They're separated by the addition symbol. First term, second term. And what kind of a binomial is it? It's a cubic binomial. Why? Because the degree of the binomial is 3. The highest exponent of these 2 terms is 3. So it's a cubic binomial. Here you can see this is a cubic monomial. It's 1 term with an exponent of 3. This is a quadratic monomial. It has a degree of 2, so therefore we call it quadratic. It's still just 1 term, so that's why it's a monomial. Where is an interesting one? They're all interesting. Check this out. You can see here, this is a quadrinomial because it has 4 terms, 1, 2, 3, 4, and the highest exponent is 2. Even on this one, on this term right here, 2x1, y1, the degree of this term is still 2 because 1 plus 1 is 2. So this is a quadratic term. That's a quadratic term. This is a quadratic term. They're all quadratic terms, except for this one. This is has a degree of 0. So if the highest degree of the different terms is 2, then that's why we can say that is a quadratic quadrinomial. Numbers are, you can just consider them to be constants, and they have a degree of 0. So, the degree of a term is the sum of all variable exponents in a term. So this is going to be, the degree of that term is 8, the degree of this term is 6, 4, 9, and 0. I just got that from the exponents. So therefore the degree of the polynomial overall is going to be 9. That's the degree of the polynomial. It's 9. Next example. The degree of this term is 4. The degree of this term is 3 plus 1, which is also 4. The degree of this term is 5, and the degree of this term is 6. The degree of this term is 0. So you add up all the exponents, even if you don't see them. There's an unwritten 1 right here. And then the degree of the polynomial is 6. Combine like terms. Well, like terms are terms that have the same variables and exponents. So, I've color-coded them. You can see that x cubed y squared, those are like terms. But x squared y cubed, that creates a different term. You can't combine those. 5 plus 4 is 9, so we have 9x cubed y squared minus 2x squared y cubed. That is the combined answer. Here, xy squared, they combine to get 7xy squared. A different term would be negative 4. These are like terms. So 4x squared y. Remember, like terms have to have the same variables and exponents. Here, lots of crazy stuff going on. It's okay. What I'd like for you to do is, now that I've color-coded these, I want you to combine these two terms together, and you tell me the answer. Pause the video for just a moment, combine those terms, and then write down the answer. Here you can see we've got 4 different kinds of terms, and we've got the two polynomials are separated by parentheses. We want to add them together. So we're going to combine the x cubed terms. 3 plus negative 7 is negative 4x cubed. The green ones are x squareds. 4x squared minus 2x squared gives you negative 2x squared. Negative 7 and positive 3 gives you negative 4x. And negative 2 plus positive 1/2 gives you negative 3/2. There's the answer. So here, not a whole lot of like terms. In fact, there's only one pair of like terms to combine. This green one right here, p squared, q squared. All the others are not like terms because although they have, I see p's and q's everywhere, but it's got to be exactly the same. Exact same exponent and exact same variables. So I'm going to write out 5p squared q to the 4th minus 2 plus 3, that gives you a positive 1 p squared q squared. And then I'm just going to write out the rest of them. 3q minus 6pq plus 5. By the way, for your audio check, I just want to let you know that I've got 2 kids. At the time of this recording, I have 2 kids. Their names are Elliot and Anna, and I'll show you pictures in class. How fun. Subtracting is very much like adding, except with one small difference, and that is this. This subtraction symbol changes all the signs of the second number. I think it's easiest to change subtraction into addition, and then make sure you have the symbols reflected of that change. So change the signs of all the terms that on the second polynomial. Like terms, we can see that we've got a couple of x y to the 4ths. That's 5 plus 3, which is going to be 8x y to the 4ths. And notice again that I made this positive because we were subtracting a negative, so it just turns into a positive. I'm going to combine the xy squareds. Negative 7 plus negative 2 is negative 9xy squared plus 4x squared minus 3 plus 2y minus 4. All of those terms cannot be combined, so there, we've subtracted as much as we can. Here. Again, we have subtraction, so I'm going to change subtraction to the addition of the opposite. Opposite, opposite, opposite. Change all the signs. So you can see here, we've got x squared y terms. 5 plus negative 2 is going to be 3x squared y. I've got some x cubed y squared terms. Negative 7 plus negative 2 is negative 9 x cubed y squared. There's only one x squared y squared term. There are 2 y terms. 4 plus 5 is 9. And then we have 1 5x squared y cubed. Some people also enjoy crossing them out after they've just so you can make sure that you got them all. X squared, we got that one, and that one. Yeah, good. We got them all. Next, 10. So that's how we add and now subtract polynomials. How do you multiply them together? We're going to get organized, and the way we organize ourselves is very much the way we organize 432 times 11, for example. 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. Make a 0. We're going to make a 0 soon when we multiply polynomials, but we'll do the same thing here. 2, 3, 4. And then we're going to add 2, 5, 7, 4. The way you organize yourself here is going to be exactly the same way you organize yourself here. Three x squared y minus 2xy plus 3y times xy 2y. Notice that I've got like terms in columns here. This is the xy column, this is the y column. Like terms. So, we're going to multiply just like we used the previous multiplication. 2y times 3y is 6y squared. 2y times negative 2xy is negative 4xy squared. 2y times 3x squared y is 6x squared y squared. 0. xy 3y, 3xy squared. xy 2xy is negative 2 x squared y squared. 3x squared y is going to be 3x cubed y squared. Notice that often these terms are going to be like terms. So we add all the like terms. 6y squared, this is negative 4 plus 3 is going to be negative 1 x y squared. We're adding the like terms. 6 plus negative 2 is 4x squared y squared, and 3x cubed y squared. This is our answer. Alright, I'm going to change this so that it's a little bit easier. As you can see on your sheet, it's 3x squared minus 2x plus 3 times x plus 2. Well, I'm going to write it down here. 3x squared minus 2x plus 3. Because they're all in kind of a descending order, you know, the squareds on the left and the constants on the right, it'll allow the columns to be columns of like terms. 3 times 2 is 6. 2 times negative 2x is negative 4x. And 2 times 3x squared is going to be 6x squared. And a 0 puts there, x times 3 is 3x. X times negative 2x is negative 2x squared. And x times 3x squared is 3x to the third. Notice that all the like terms are in columns, so I can just add them. 6. Negative 4x plus 3x is negative 1x. 6x squared plus negative 2x squared is 4x squared. And we've got 3x cubed. This is your answer. Here I'm going to change this so it's a little easier. And it looks like this. So now we have 2 times 3, which is 6. 2 times negative 7, negative 14. X squared. 2 times 4 is 8. X to the fourth. 0. I think the most satisfying part is just writing that 0. It's great. Negative 3 times positive 3 is negative 9. X squared. Negative 3 times negative 7 is 21. X to the fourth. And negative 3 times 4 is negative 12. X to the sixth. Add them up. Like terms give you this. 8 plus 21 is 29. X to the fourth. Negative 12x. Negative 12x to the sixth. And there's your answer. Here, now we could we could multiply like this, but we're not going to. Another technique that people use a lot is called FOIL, where you multiply, and it works only for binomials, so two binomials you can FOIL. These are what we call the first terms, F. These are the outside terms, O. These are the inside terms, I. And these are the last terms, L. So the first terms you could say are 2xy times x squared, which is just going to be 2x to the third y. Outside terms are 2xy times negative 2, which is negative 4xy. Inside terms, 3x times x squared is 3x cubed, and last terms 3x times negative 2 is negative 6x. If there's any like terms, you add them up, but if not, then you can say that you collect them, and then this is your answer. 2x cubed y minus 4xy plus 3x cubed minus 6. That's your answer. Let's FOIL number 13. You've got the first terms are 3x and 5x, which is 15x squared. You've got your outside terms, 3x times 3y is 9xy. Inside terms, negative 2 times 5 is negative 10xy. And your last terms are going to be negative 2 times 3, which is negative 6y squared. Now the O and the I are actually like terms, so we can add them up. They often will be like terms. So we get 15x squared as an answer. Negative 10 plus 9 is negative 1xy minus 6y squared. So in general, you have a plus b and c plus d. That becomes first ac, outside AD, inside BC, and last BD. Here, we could FOIL this. In fact, if we did, it would be 4x minus 5 times 4x minus 5. We could do first, outside, inside, last. But if you notice, the outside and the inside terms are always going to be the same. And they're always going to be, so you can just double them. The outside and inside terms are going to be the same, so you just double them. Let me just show you what that looks like. First terms would be 16x squared. Outside terms are negative 20x. Inside terms are also negative 20x, and last terms are positive 25. It's actually a lot faster and a required to memorize shortcut to say that you have, this is the answer. A faster way to do this would just be to say that, look, this is the A is 4x, B is 5, so the answer is going to be a squared plus 2ab plus b squared. I'm getting that from the formula that I showed you on the other side of the page. So a squared is going to be 16x squared. 2ab is going to be 2 times 4x times 5, which is negative 40x. B squared is 5 squared, which is 25. So when you see this kind of, when you see the square of a binomial, then I want you to use this formula here. And we need to have this memorized. There are 3 ways you can memorize it. You can make some flashcards if you want, and that's fine. We can practice it, which we're doing now, and we'll do in class. And then you can also make sure you write it out each time. I know other teachers don't require you to write things out, but I think it's best for memorization if we write it out like this. A is going to be 2y squared. B is going to be equal to 6. So therefore, if we have a plus b squared, then the formula says that the same thing as a squared plus 2ab plus b squared. What is a squared? That's going to be 2y squared squared plus 2y squared times b, which is 6. And b squared is 6 squared. Let's simplify. We've got 4y to the 4th, because 2 times 2 is 4. We've got 2 times 2 is times 6, which is 24, y squared, plus 6 times 6, which is 36. Let's write this down every time so that we can memorize it. And this is what it looks like. Here's the formulas, and notice that if you ever have subtraction, then it would be minus 2ab. Oops. Which I need to fix here. Good, that's a squared minus 2ab plus b squared. Now here, we could FOIL this again, and in fact maybe I will. I'll show you what FOILing looks like. When you have 4x plus 7 times 4x minus 7, you get, oh no, I won't even FOIL, I'll do the multiplication. Negative 7 times 7 is negative 49. Negative 7 times 4x is negative 28x. You could FOIL, but I'm going to do that here. 4x times 7 is positive 28x, and then we have 16x squared. Add them up. Notice that these terms cancel out. They would be in FOILing, they'd be the outside and inside terms. So we're just left with 16x squared minus 49. There's a shortcut here. And the shortcut says that if you have two binomials that are exactly identical except for there's an addition and subtraction, then you can just say it's a squared minus b squared. We call these the conjugates right here. These two binomials are conjugates of each other. They're exactly identical except for one is addition and one is subtraction. So the way I'd prefer you to do this would be to just say, hey look, we've got a is equal to 4x, b is equal to 7, so what I really have is just a plus b times a minus b. And that's from the formula that I have memorized. It's really just a squared minus b squared, which is going to be 4x squared, 16x squared, and 7 times 7 is 49. So this is our preferred method for these kinds of problems. Let's do the same thing here. Yes, we have conjugates, two binomials that are exactly identical except that there's addition and subtraction. I'm going to let a equal 5x squared, and I'm going to let b equal 2. Therefore, what I really have is a plus b and a minus b. I know from the formula that when I multiply that out, it's a squared minus b squared. A squared is going to be 5x squared times itself, which is 25x to the 4th, minus 2 squared is 4. And that's it, folks. I'll see you in class.